morning, viewers. This is Kasturi Day. Today I'm going to start with the atomic structure, okay? And rather atom and its structure. So before that, I would request you to please do subscribe my channel and do ring the notification bell if you have not done so. And if you're liking the video, press the like button, share with your friends so that they can also be benefited from this video. And also do meditate before starting your day. Okay, so I'll start with the meditation for just 1 minute and then we will continue with the discussion. Okay, so first for meditation, think of a point of light. Think to be bulb, you can think that as a point of light, consider that a point of light, so that it is reaching you. The light from the bulb is reaching you, filling you up. Before you close, is lightened up with that light which is coming on you. It is helping you to gain energy. The lights are making you joyful, happy, motivated. You're feeling interested, you're feeling energetic in whatever you're doing. And you do the job very nicely, becoming successful, getting good results. So this is making you happy to proceed your day, your life. So let's start here. You can follow this meditation. Continue this every time you start your job. Okay? You work you do, that will help you in gaining energy and gaining motivation. So let's start here, and we'll continue with the discussion. Before I will start, I will tell you the previous videos. In my previous videos, I've discussed the atomic subatomic particles, that is the proton, neutron, and the electrons. So in a nutshell, an atom is a building block of matter which is used to determine the characteristics of an element. Okay? An element, the characteristics of an element can be determined from the atom. Okay, so the atoms are made up of 3 basic components or 3 basic subatomic particles. Okay, mainly protons, neutrons, and electrons. Protons have a positive charge, neutrons have neutral charge, and electrons are negatively charged. Okay, so the atomic structure of an element refers to the constitution of its nucleus and the arrangement of the electrons, which are revolving around it in an imaginary path, which are known as orbits. Okay, so atomic structure, by atomic structure, what do we mean? That it has a nucleus, and which has the nucleus which contains the protons and neutrons, and the electrons which are revolving around it in an imaginary path which is known as orbit. Okay? Now, the nucleus is at the center of the atom, consisting of protons and neutrons, which together are known as nucleons. Okay, protons plus neutrons are termed equal to nucleons. Okay, now the orbits are the imaginary paths where the electrons revolve around. Okay, they around the nucleus of an atom. Okay, so nucleus is at the center, which contains protons and neutrons together. These protons and neutrons together, they are known as nucleons, and it has the orbits which are there outside the nucleus. Okay, they are imaginary parts, and they are on those orbits. The electrons revolve around the nucleus of the atom. Okay. Next this is the picture of the structure of an atom. See, this is the nucleus which has protons and neutrons. Protons are, see, here it's orange balls, and the blue balls are of neutrons. Okay, so protons and neutrons are arranged inside the nucleus, and together they are known as nucleons. Okay, and both form the nucleus. Combining together, they form the central part of the atom, which is known as the nucleus. And there are orbits which are imaginary part around the nucleus on which the electrons move. Those are known as orbits or energy levels or shells. Okay. Now we come to atomic number. What do you mean by atomic number? It is the number of protons in the nucleus of an atom. That is the atomic number of an atom. Okay, so the total number of protons which are present in an atom, that is known as atomic number of that atom. Okay, or you can say the number of electrons which are revolving around the nucleus of an atom is known as atomic number, because number of protons is equal to number of electrons. That's why one and the other is the same thing. Now it is represented with the letter Z. If you write a letter Z, that means it is the atomic number of that element. Okay. Now all the atoms of a particular element have the same number of protons and hence the same atomic number. So all the atoms of a particular element, like see if an element has 6 atoms, for example, so all the 6 atoms will have the same atomic number as they have the same number of protons in them. Clear? Now atoms of different elements have different atomic numbers. Now atoms of hydrogen, atoms of oxygen, atoms of carbon dioxide, so all they have, there are different elements, that is hydrogen, oxygen, carbon, all are different elements. So atoms of these 3 elements, they have different atomic numbers because they have different number of protons. Clear? Now, for example, all carbon atoms have a atomic number of 6, whereas all the atoms of oxygen have 8 protons in the nucleus. Okay, so carbon has atomic number of 6, because it has 6 number of protons, whereas oxygen have 8 protons, therefore the atomic number of oxygen is 8. Clear? Now the atomic number is equal to the number of electrons in the neutral atom of an element, as number of protons is equal to number of electrons. Okay. That's why I told you that number of protons, if you tell that number of, the atomic number of an atom is equal to total number of protons, it can also be the atomic number of an atom, of an element can also be the total number of electrons present in it. Now, the number of protons gives the total positive charge which is present in the nucleus of an atom. Okay, so the number of protons which is equal to the total positive charge which is present in the nucleus of an atom. Next is mass number. So atomic number is the number of protons or the number of electrons. So that is atomic number, which is denoted by capital Z. Now we come to mass number. Mass number is denoted by capital A. Okay, and it is also called the atomic mass number, or you can say nucleon number. That means it is the total number of neutrons plus total number of protons in it. Total together we known as nucleons. So total number of nucleons in an atom is known as, in an atomic nucleus, is known as the mass number. Clear? It is approximately equal to the atomic, also known as isotopic mass of the atom, which is expressed in atomic mass units. So it is approximately equal to, this mass number is equal to atomic mass or isotopic mass. It can be called atomic mass or isotopic mass of the atom, which is expressed in atomic mass units or AMU. Okay, short form is AMU, so atomic mass unit. The difference between the mass number and atomic number, because mass number is bigger because it's a sum of number of protons and number of neutrons. Okay, and atomic number is only the number of protons. So mass number minus atomic number gives the number of neutrons in a given nucleus. That is capital N. So capital N is equal to capital A minus capital Z. Clear? For example, an atom of carbon has 6 protons and 6 neutrons. So its mass number is 12. 6 plus 6, that's 12. Now, as it has 6 protons, okay, and mass number 12, so the number of neutrons will be 12 minus 6. That is 6 neutrons. Clear? Now, while the number of protons remains the same in all the atoms of an element, the number of neutrons can vary. Thus, atoms of the same element can have different mass numbers and they are called isotopes. Okay, so we know that all the atoms of an element, they have the same number of protons, but it is also said that it can vary its number, its mass number. Atomic numbers may be same for all atoms of an element, but mass number for all atoms can differ, cannot be same. And that leads to the discovery of isotopes. That is, the number of neutrons may change. The total number of neutrons may change from one atom to another atom of the same element. And that leads to the formation of isotopes because their mass number changes. The weight of an electron is almost negligible. We know the weight of an electron is 1 by 1837 of hydrogen atom. So it's very, very less. It's almost negligible. Therefore, the atomic mass of an atom is almost the same as its mass number. Atomic mass of an atom is almost same as the mass number. Okay? As its electrons weight is almost negligible. So there can be a question why you can say that atomic mass of an atom is almost same as its mass number, because its electrons weight is almost negligible. Clear? Next, we move on to distribution of electrons in the orbits of Bohr-Bury scheme. Okay. Now, distribution of electrons, it's a Bohr-Bury scheme now we come to. So, distribution of electrons in the orbit means electronic configuration. How the electrons are arranged in their orbits, in the different shells, that is known as electronic configuration, which was given by Bohr-Bury. Okay, the scheme was given by Bohr-Bury in 1921 to find out the electronic configuration of atoms, that is, the number of electrons in their orbitals. The scheme is known as Bohr-Bury scheme. According to this scheme, the maximum number of electrons in a class or in an energy level is 2n square. 2n square is the formula by which the electrons are arranged in a cell, where n means the serial number of that class, serial number of that energy level, serial number of that orbit. Okay, I told you before that the energy levels or the shells are arranged in 1, 2, 3, 4 like that, or K, L, M, N like that. Okay, from the nucleus to the outside. So 1, if the first class is 1, okay, then the number of electrons in that will be 2n square means 2 into n is 1. So 2 into 1 square, that means 2 into 1, that is equal to 2 number of electrons must be there. Maximum number of 2 electrons must be there in the first shell, first class or first energy level. Okay. Now, if n is equal to 2, that is in the next class or the next shell or the next orbit or the next energy level, that is 2. Okay, so that time what happens, the maximum number of electrons will be 2 into n squared, that is 2 into 2 squared, that is 2 into 4, that is 8 electrons. Maximum number of electrons in this class will be 8. Similarly, on the third, the fourth, it will be 18 and 32. If you put this n square number according to the shell, then you will find the maximum number in the third shell will be 18, fourth will be 32, like that. Okay. Next is the number of electrons in the outermost orbit of the cannot exceed 8. Outermost orbit. Any of the atom which has an outermost orbit, it has to be, maximum number should be 8. It cannot exceed that 8. The number of electrons in the orbit, penultimate orbit, cannot exceed 18. Okay. So like potassium, which has 19 as an atomic number. So the first cell, it will be 2. The last cell, it should be 9. It should be, see, 2 plus 8, that means 10. And the last shell has 9. But 9 it cannot be because the last shell maximum has 8. And the penultimate 18. Okay, penultimate means the before the last one. Okay, so it should be 2, 8, then 8, and then 1. Okay, it cannot be 9. Okay, so the maximum number of electrons in the first class will be 2. After having 2 electrons in the first orbit, like this, the K orbit, electron starts filling up in the second orbit, that is the L orbit. After filling that orbit with 8 electrons in the second orbit, that is L orbit, electrons start filling the next orbit, third orbit. Okay, third orbit, again, it can fill up till 18. But it is becoming the last or the penultimate orbit. Okay, if it is last, then it is to be filled up by maximum number of 8 electrons, not more than that, but 9 electrons are left. Okay, so that means 1 electron has to move to the next orbit. Okay, so the penultimate orbit will contain 8 electrons, and the last orbit, that is K, L, M, and N. N orbit will contain 1 electron, and M orbit will contain 8 electrons. Clear? Therefore, the electronic configuration will become according to 2n rule, and it will be 2, 8, 8, and 1. The cells are filled in the stepwise manner. So this is the magnesium atom which has been filled up. The atomic number is 12 and atomic mass is 24. So neutrons will be 24 minus 12, that is 12 neutrons, which is blue in color. These are the blue neutrons, and the red one are the 12 protons present, and the green are the electrons which are occupying in the shells. Okay. K, or the first cell, has 2 electrons. L has 8 electrons because atomic number is 12. So how much? 2 and 8, that means 10. So 2 electrons are left. Now 2 electrons will be on the third shell. Clear? So the configuration will be 2, 8, and 2. Now note, in lighter elements, like up to argon, where the atomic number is equal to 18, each inner shell is completely filled before any electron can occupy an outer shell. When it is moving to the outer shell, the inner shell has to be filled up fully. Especially this happens in the lighter elements up to argon. Okay. In heavier elements than argon, the fourth cell begins to be filled after it has 8 electrons, in spite of the fact that the third shell can accommodate up to in heavier elements. What happens? The argon, like other than argon, the fourth shell begins to be filled up after it has 8 electrons. So 8 electrons, the fourth shell is filled up. Then the the penultimate shell is filled up, the third shell is filled up, and then there comes the fourth shell. Okay, the third shell becomes 8 electrons, and then the other electrons, they have the fourth shell. Okay, it begins to be filled up after it has 8 electrons in the third shell. It can accommodate up to 18 electrons in the third shell as per 2n square rule. As per 2n square rule, the third shell can be 18 electrons. Okay, but so 18 has been missed up here. So please, you can mention it. It is to be 18 electrons in the third shell according to 2n square rule. But after that, what happens as it is the penultimate shell? So it will have 8 electrons in the third shell, and the fourth shell will be filled up then. After the filling up of 8 shells in the third shell, the fourth shell starts filling up. Okay. Like, for example, potassium, which has 19 number of atomic numbers, so 19 electrons it has, and its electronic configuration will be K is equal to 2, L is equal to 8, M is equal to 8, and N is equal to 1. Clear? Now we come to valence electrons. Now, valence electrons means what? The electrons which are present in the valence cell, that is outermost cell, which determines the valency of an atom, of an element. Clear? So the valence electron is an electron which is present in the outer shell, that is the valence shell, which is associated with an atom that can participate in the formation of chemical bond if the outer shell is not closed, and also it takes part in the chemical reaction. Okay, so it gives the valency. That means if it is not closed, if the outer shell is not closed, then what happens? It will form a bond, a chemical bond it will form. It may be covalent, may be ionic, it can be covalent or ionic bond. Okay, and it can take part in the chemical reaction. In a single covalent bond, both atoms in the bond contribute one valence electron in order to form a shared pair. When one atom of an element is combining with one atom of another element, and then what will happen in single covalent bond, both atoms will share one electron and it will form a shared pair. That is a single covalent bond. The presence of valence electrons can determine the element's chemical properties, such as its valency, whether it may bond with other elements, whether it may bond with other elements. Okay? The combining capacity can be known from this valence electrons. Okay? For the main group elements, the valence electron exists only in the outermost electronic shell. Okay? So for the main general group of elements, the valence electron remains only in the outermost electronic shell. The valence electron can exist in the inner shell of a transition metal. Transition metal, the inner shell also can contain the valence electron. An atom consisting of a closed shell of valence electrons will usually become chemically inert, like in rare gases or in inert gases, you can say, that is argon, helium. All these are, the shell are closed. That means their shells are filled up with a maximum number of electrons. Then those type of shells, they are chemically inert. Those type of atoms are chemically inert. Okay. Now, a valence electron can either absorb or release energy in the form of photon. Okay. They can absorb or release energy in the form of photon. Valence electrons also determine the electrical conductivity of an element. Okay. It can also determine the electrical conductivity of an element. That is, it can conduct electricity or not. Okay. Now, depending on its depending on its nature, the elements can be metal. On this nature, if we depend, then we can say the elements can be metal, non-metal, or a metalloid. The elements with the same number of electrons in the valence shell show the similar properties, where the elements with have different number of electrons in the valence shell will have different properties. The elements which have 1, 2, or 3 valence electrons are metals. The valence electrons, if it is 1, 2, or 3, then it can be metals except hydrogen and helium. Okay, because these are non-metals, but still they have 1, 2 electrons in the outermost shell, 1, 2, or 3 also. So these elements are generally metals, and metals can lose electrons to form positively charged ions, and they are those type of ions are known as cation ions. Like see sodium, it has the atom of sodium contains 2, 8, and 1 electron. Electronic configuration is 2, 8, 1. That means it has 1 electron in its valence shell. It will lose that 1 electron and it will become a positively charged ion. Okay, and that will be Na plus. That is 2 and 8 will be the electronic configuration in its ionic form. They are good reducing agents. These metals are generally good reducing agents. They will reduce the substances, okay, and get itself oxidized. That is, the elements with 4 or 5 or 6 or 7 electrons in their valence shell are non-metals. Okay, the elements with the 4, 5, 6, or 7, these are the in the valence shell. If they have these type of electrons, then they are non-metals, and non-metals can gain electrons to form negatively charged ions, and they are called anions. Like chlorine, these are anions, and these form anions because chlorine atom has an electronic configuration of 2, 8, and 7. So 7 electrons in the valence shell, and it will gain 1 electron to form an octet. Okay, and it will gain 1 electron. That's why after it gain 1 electron, and it will form a negatively charged ion, that is chlorine ion or an ion of chlorine, which is 2, 8, and 8 electronic configuration. And these are good oxidizing agents. They oxidize other elements while it gets reduced. Okay. Now, elements which possess both the properties of metals and non-metals, they are known as metalloids. Okay, if they gain the properties of both the metals and non-metals, they are metalloids, and they can be there can be 3, 4, 5, 6 valence electrons in the metalloids, valence electrons in the metalloids. Okay, for example, boron, silicon, germanium, arsenic, etc. These are all metalloids which have 3, 4, 5, or 6 valence electrons in their outermost shell. Okay, now elements with the valence shell having 8 electrons on their outermost shell or 2 electrons in case of helium, these are known as inert gases, noble gases, or rare gases. They cannot gain or lose electrons because they are chemically inactive or inert. Okay, their total shells are closed. They do not share or do not gain or do not lose electrons, and that's why they are chemically inert or inactive. Okay. So this forms the valency. This valence electron, I told you, this forms a chemical bonding in all elements. This valence electrons, and that determines the valency of an element. It is the property of an element that determines the number of other atoms with which an atom of an element can combine. It is the combining capacity of an element. Valency is nothing but the combining capacity of an element with other elements. So it is also equal to the number of electrons that can take part in the chemical reaction. Okay. So valency of an element having 1, 2, or 3 valence electrons in the outermost shell is 1, 2, or 3. Valency will be also 1, 2, or 3. Okay, respectively. If it is having 1 electron in the outermost shell, valency will be 1. If it is having 2 electrons in the outermost shell, the valency will be 2. If it is having 3 electrons in its outermost shell, the valency will be 3. Okay, but if the valency of the elements are 4, 5, 6 valence electrons on this outermost shell. Valence electrons of an outermost shell is 4, 5, 6, or 7. Then its valency will be 4, 3, 2, and 1. That will be the valency of the electrons. The statement is written wrong, so I'll please rectify it. If the valence electrons in its outermost shell is 4, 5, 6, or 7 electrons, then the valency will be, if it is having 4 electrons in its outermost shell, the valency will be 4. If it is having 5 electrons in the outermost shell, then it is deficient of 3 electrons. That's why it will have a valency of 3. Okay, if the valency of an element is having 6 electrons in its outermost shell, then it is deficient of 2 electrons to form the octet. That's why its valency will be 2. Okay, and if it is having, if an element is having 7 elements in its outermost shell, then it is deficient of 1 electron in its outermost shell to form the octet, and that's why its valency will be 1. That means 8 minus the valence electrons will be the valency of that element. Okay, so like that we calculate the valency of an element. Okay, so I'll stop here. I'll continue with the rest of the discussion in my next video. It's a big chapter, and after this chapter we will continue with the periodic table. We'll start with the periodic table. I've started this chapter because this will help you in understanding the periodic table, how we can deduce the periodic table where the metals and non-metals are arranged in that way. Okay, on the basis of valency. Okay, so that will help you on this the arrangement of the electrons, protons, and neutrons. Okay, so that's why I started this atomic structure first, and then I will start on the periodic table, because this atomic structure chapter you have read so many times. This is just a revision of this chapter, and then we will proceed to the periodic table. That will help you understand the periodic table much easier. Okay, much better you will understand it. Okay, so I'll stop here. I'll continue with the rest of the discussion in my next video. Till then, go through this. If you have any doubt, please do write in the comment box. You can also write in my email ID, that is kasturi74@gmail.com, and you can also you please do subscribe my channel. If you are not subscribed yet, do ring the notification bell so that any new video is uploaded, that will help you in getting the notification first. And if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos, and do meditate before you start your day. Okay, so thank you for joining, and have a good day.